All right, good afternoon, Warriors. I hope you are well. It's good to see all of you, and we will go ahead and get started with the party. Looking at the screen, here's our map check for today. Actually, this is gone. Come on, lag. Let's get rid of this. All right, back on track. Here we are, Thursday, the 23rd of April. We're going to go after population mean hypothesis test today with sigma unknown, and that'll be the last of us doing this kind of 4-pack method. Coming up on Sunday, we've got homework 3 alpha, homework 3 bravo, homework 3 Charlie. Again, that sounds like a lot. It's a total of 6 problems. So I'm not saying that it's not going to take, quote, some time, but it's not 16 problems, okay? And 3 alpha, 3 bravo, 3 Charlie are aligned with how we've gone after the material. So that's all there. Do it Pearson, or do Sunday at the normal Billy Idol time. Not on the screen, but I just briefly want to talk about next week. On Tuesday, we're going to get after regression. And then on Thursday, we're going to do kind of a regression drive and start to get into our final drive work. The week beyond that will all be hands-on. Okay, so that the week beyond next week, we'll use both sessions. We'll have Zoom both times. We'll get our hands dirty. We'll roll up our sleeves. We'll get ready for that final exam. So we'll go over hypothesis tests. We'll go over regression. We'll go over a little bit of descriptive statistics. Again, that's not next week. That's the week after. Okay. Any questions so far on the map check? Anything else?
Didn't you say we were going to get a regression assignment?
Yeah, so that's not on the screen. That's a good question. So that regression assignment, I will post probably early next week, no later than Tuesday, and it'll be due a week from Sunday. Okay, so not this Sunday, but the next Sunday. Does that answer your question, Greg? Okay, and that'll be the last homework type of thing, and I'll talk more about that. Okay, any other questions on what's on the screen, map check kind of stuff? All right. Stand by. Okay, looking at our agenda for today, we're going to go after mean hypothesis testing for pack 3, where sigma or the standard deviation is unknown. So here's what we're going to do today. I've already got my recording going on. First thing in the agenda, I just want to say this, and I'm going to say it one time or one last time and be done with it. 2 weeks from tomorrow, I will assign my assessments of class interaction and participation. I've put this out in writing. I'm just going to go over it one last time, and I don't want to talk about it anymore, except if people have questions or want to talk about it. It's relatively simple. Obviously, we've changed our method of education and going after the war on knowledge. And so I've published some modifications. But first things first, to participate, you got to be present in class. I mean, you physically have to be in present. And then beyond that, I hate to talk about expectations that I look for, but it is what it is. I look for certain things to see if you are not just physically present, but you are participating and present. So standards that I expect are that your screen is unmuted. I can see you. It's not a static image of you. It's not a black screen, that you're there. Other expectation is that when you're called upon, that you respond, either by audio or by typing in on the chat. Typing in on the chat is not the usual method, but if you have audio and video difficulties, then You got to do what you got to do. Now, if you are hampered or unable to participate that way, then you kind of got to talk to me about it. I don't expect everybody to run out and buy a $300 webcam. That's not that. It's actually the opposite of what I'm talking about. But if you have a computer without a camera, or you have difficulties or something going on, then I really need to kind of hear from you. Otherwise, after a while, I just kind of assume that other things are happening. Okay. And I wake up in the morning thinking good things about all of you. I'd like to keep it that way, but sometimes in the absence of knowledge about what's going on, I come to other conclusions. So these are easy points. That's the last time I want to talk about that, unless anybody has any questions on that or anything else. Moving along, we're going to play the frame game today, and then we'll get after mean hypothesis testing. So let's get oriented. Before we get into the frame game, once again, here's where we are in Disneyland or the mall or the zoo. So we've talked about hypothesis tests with the population proportion. Then last time we talked about hypothesis tests where we know the standard deviation of the population. Today, we're going to talk about hypothesis tests where we don't know the standard deviation of the population. Okay, so that yellow box is where we are. Again, in my mind, in any different situation, there's only 4 ways to twist the problem. And so if you figure out what those 4 ways are, and I have them on the next slide, and you assess yourself on your ability to recognize the situation and then solve the problem, I honestly feel, and I've beat this dead horse, that you will be better off if you know where you're at and where you're not at. So please use this and the following slide as a guide. This bottom bracket is just a drill down on the previous slide. The bottom line is when we are in this situation, we are rolling with the T distribution. Okay, Z is our friend, but we've got to park it somewhere else. When we recognize that the standard deviation for the population is unknown, we have to use the T distribution. All right, and then from there, we have a lot of commonality. We do have some differences in using the T distribution, and we'll get to that later today. Okay, so that sets the stage for today. Let's warm up our mind and body a little bit. First, a quote. I ran across this yesterday and thought it was pretty cool. Kind of captures the essence of D3M and where you should see yourself coming out of the way of the warrior and almost at the pinnacle of this class. I love the quote, "Without data, you're just another person with an opinion." And to me, this really starts to separate the amateurs from the professionals, the warriors from everybody else, where you can drop that science with defiance. And that is what this course is really all about. So I thought this was pretty cool. All right, so frame game, bravo. Let's warm up and let's check it out. So all we're doing here is 2 things for each one of these. We have 3 situations. A, we're going to identify the null and alternative hypothesis. And then B, we're just going to talk about if the null is rejected, what the person might do. And if we fail to reject the null, what we might do. Okay, so let's check it out. Emma is convinced that the bus that travels from East to West Campus, a little Spartan bus, is taking longer than normal. Here's why she thinks this. Before, if she missed a bus, so she's coming out of class, kind of hurrying, she sees that bus taking off, doggone it, I missed it. She only had to wait 10 minutes before another one would arrive. But lately, it seems like she's having to wait longer. And if the bus is taking longer, meaning she turns out that she believes the bus is taking longer, maybe through a hypothesis test. She wants to file a complaint. All right, so that's our setup. Okay, so let's see. Let me get my pen fired up so I can write on the screen a little bit. Probably have some residual stuff. All right, so Matt, what do you think the null hypothesis is here?
Is it I'm not quite sure.
Okay. Justin, what do you think?
I'm not quite sure either, to be honest.
Okay. Amir, what do you think? Thomas, what do you think?
Is it mean is not equal to 10 and then mean is equal to 10?
Okay, we're headed in the right direction. Let's take a look at our language. Is taking longer than normal? This is a big hint phrase right here. Brianna, what do you think? How should we fill this in?
Is it the first one, is it less than or equal to, and then the bottom one would be greater than?
That is correct. Okay, so this keyword up here, or the key phrase, is taking longer than normal. Okay, and literally, this is the status quo. Now, make no mistake, this is what Emma believes is happening. Okay, and that's why we park that as the alternative hypothesis. But to have any traction in her argument, she first has to either reject the status quo or fail to reject it. Now, let's suppose that Emma runs her hypothesis test and she rejects the null. All right, Jennifer, if she rejects the null, what might she do next?
So she's rejecting what she thought was the issue. So I don't know if maybe she would continue to search for more data, or if she would just accept that the normal time is indeed what it is, the 10 minutes.
Okay, so in this situation, Emma rejects the null. All right. So Cynthia, if she rejects this null hypothesis.
Oh, the null. Okay, sorry, I was thinking it was the alternative.
Yeah. So Jennifer, either one, Jennifer or Cynthia or both in harmony. What do you think? If she rejects this null hypothesis, what might Emma do next?
File a complaint to say that it, like with her data, it did show that it was greater than 10 minutes, and it showed them the data to have proof about her complaint.
Exactly. And Jennifer, I think that's you were on there. You just,
Yeah, I was just backwards for whatever reason.
yeah. And it happens. And so when Jennifer says for whatever reason, that's why we do this, because it happens all the time. It's this kind of backwards thinking that we've got to get our brain into this pattern. So it's very understandable, but and I kind of covered it up, not on purpose, but conversely, if she fails to reject, and this is kind of what Jennifer was saying, let's say she fails to reject this null hypothesis, then she's just kind of got to live with it, or maybe collect more data, So when I say live with it, maybe before she does her hypothesis test, she's going around telling people, hey, I know that bus is late. I know that bus is late. Well, if she fails to reject, she kind of needs to quit saying that, because otherwise she's like old, Deming says, she's just a person with an opinion, but she doesn't really have grounds to go around saying that the bus is taking longer. Okay. All right, let's go on to another one. And these get harder as we go. All right. Walter is on trial for producing meth. The DEA has seized a major meth lab. In order for the prosecution to have a strong case, Walter's fingerprints must be, I have a little typo, I'm sorry, must be a 51% or greater match with the fingerprints found on the meth lab equipment. Okay, so the DEA has seized this location. There's all sorts of beakers and vats and all this industrial stuff, and there's fingerprints all over the place. But for the DEA to have a strong case, they've got to have a match of 51% of greater between Walter's fingerprints and the fingerprints they found on all this stuff. Hank is the DEA agent leading the investigation. To have an unbiased approach, what should his null and alternative hypotheses be? Okay, so let's think about this for a second. Megan, what do you think? Why don't you start us out with the null? What should the null hypothesis be in this situation?
So I think that it's the population proportion
Okay, good.
is it's either going to be equal to or greater than or equal to 0.51.
Okay, so you think it looks like this?
I think so.
Okay. Max, what do you think? You good with this?
Why would we use P-pop in that example and not like uh, sample mean?
So does that look like a sample mean, or does that look like a proportion?
It was a proportion. I don't know. I was thinking, yeah, I just had a weird way of thinking about it.
So we have all the fingerprints,
Yeah.
right, found, and then we have the amount that Walter's fingerprints, or we have all the fingerprints there, and then we have the amount. See
Yeah,
what
that
I
makes
mean?
sense. Yeah.
So that's more of a proportion.
All right.
What's
And then to answer your question, it would be is if it's less than 0.51.
Okay, so we want to turn this around.
Oh, no, like the next question.
Okay. So actually, let's see. Let's see what Lexi, what do you think? Should this go that P-pop is greater than or is less than?
I think it's less than, and then the alternative would be greater than.
Okay. Why do you think that?
I'm not really sure, to be honest.
Okay. George, what do you think? What do you think about all this?
I agree with that way because aren't we looking for, so in the alternative, we're looking for it being greater than 51%.
That's what that says.
Yeah.
Okay.
So we start with that, which makes the null less than.
So this setup is correct. Okay. And this is kind of a tip off here. All right. So essentially, if we read this, this says that the null is that Walter is innocent. Okay. Because his fingerprints are less than or equal to 0.51. All right. And if we reverse these, or even reverse these symbols, we would be putting bias into our approach. We would literally have a going in position that Walter is guilty because more than 51% of the fingerprints at the crime scene are his. Okay? So a little
So-
tricky. Yeah, go ahead.
If it didn't say anything about it being unbiased, would it be the opposite? Or would it still be the same?
It still would be the same.
Okay.
Um,
When for the null, wouldn't it just be less than 51% because instead of be 51% or greater equal to 51%?
you're talking about right here.
Yeah.
So we always have an equal sign of some sort in the null. And that is why that is there. Okay. And conversely, we never have an equal sign in that. Okay, so let's put this into context. So let's say we fail to reject actually, let's say that we reject the null. So Jared, in this context, if we reject this null hypothesis, what is the value of that? What does that mean connected to this narrative?
That would mean that he is innocent and that that's not his fingerprints at the meth lab.
Okay. Alyssa, what do you think? If we reject this null hypothesis, what does that kind of mean? How does that connect back to our hypothesis test
Okay.
anyway? So if we reject this here, Jared, did you have a change of heart? Either Jared or Alyssa.
Yeah,
what do you guys think?
I had a change of heart because when we originally started the problem, my null hypothesis was the other way around, and so that was my thinking.
Okay.
But no, that would mean that it is his fingerprints and that he is guilty.
Well, it really even simpler. Okay. And we got to be careful about our language. If we reject this null, that means that more than 51% of the fingerprints are his. It could be 52%, it could be 75%, but it means that more than 52% of the fingerprints there are his. And so it supports the DEA's approach into the case. Doesn't necessarily mean he's guilty. You see what I mean?
Yeah.
But it supports, and so it's kind of like tipping a scale. It makes a more credible argument that yes, he is guilty. It doesn't prove him guilty, but it starts to support that argument. Okay. Any questions on this one from anyone? All right, let's do one more and then we'll get into the meat and potatoes today. This might be the toughest one, I don't know, of today. So let's check it out. Let me get my stuff fired up. Helen and Cindy want to sell hot dogs at the hockey game. All right. They think that more than 55% of people prefer hot dogs over hamburgers at the local hockey rink. They asked Sloppy Joe, the concession manager at the rink, what he thinks about this. Actually, they just asked him, hey, what do you think? Do people prefer hamburgers or hot dogs while watching hockey? And he goes, I don't know, but it can't be more than 40% of people that prefer their hot dogs. All right. So let's ask somebody who knows something about hockey. Where did Kendall go? This is an interesting time. Eric, what do you think? What is our null hypothesis?
Would it be kind of set up the same as the last question? So the population proportion is less than or equal to 0.55.
Okay, so this is the tricky part. Which one of these we want to use or both? So Eric thinks we might put 0.55 there. Kendall, what do you think?
I think it's 0.47. P-pop is less than or equal to 0.47, and then the alternatives greater than, which would then, in a way, prove their point.
Okay, so I'm just going to park this aside. I think Kendall has some inside knowledge because he is into hockey and stuff. So Kendall, you went kind of faster. Let me catch up. You think what's the symbology here? Greater.
I said that's less than or equal to because he says it can't be more than 47%, and then the alternative is greater than because that's what they're trying to prove.
And still 0.47?
Yeah.
Okay. So Kendall is correct. I think it's because he knows hockey. But the tricky part, and I did this on purpose, is Helen and Cindy have this idea about 55. But they first need to see, okay, what does anybody think is the status quo? Okay. And so because they find Sloppy Joe and Sloppy Joe has this belief about the status quo, they need to first reject or fail to reject a null hypothesis that's associated with the status quo. That's why we choose 0.47. Okay. And like Kendall and Sloppy Joe said, he doesn't think it could be more than that. So it has to be either equal to or less than, which would make this the opposite. Okay. And again, this is the trickiest one because the big decision is, okay, we know that Helen and Cindy want to support this argument. Maybe there's a contract that if they could get something to support this, they could get the contract to sell hot dogs at the hockey rink. But the first thing they need to do is reject this null hypothesis and show people that they've rejected it. Okay. So I'm kind of telling the answer. If they do reject this, then they kind of have a case to be made that, hey, we did a hypothesis test. We rejected Sloppy Joe's assertion about the status quo. And there's more people interested in hot dogs than meets the eye. And so therefore, give us this contract. We can sell hot dogs there and make some mad money. If they fail to reject, again, they just kind of got to live with it, you know? They don't get the contract. Maybe they need to do some more marketing, generate some more interest, and then maybe sample and test later. Okay? But this is a good one to reflect on. They're all good, in my opinion, to reflect on, especially if you had difficulty framing this one. That's what the frame game is all about. Thinking about what you do with this narrative, what you don't do with the info, and those kind of things. Okay? Questions on this one or any part of the frame game? All right. Let's pull up our meat and potatoes for today.
Sorry about that. My iPad died.
Well, welcome back. Okay. So today we're going to talk about hypothesis testing again with the population mean, sigma unknown. This is actually a picture of the Bermuda Triangle, which I grew up watching shows about all this kind of unknown stuff. Really neither here nor there. I got some lag. Here we go. Here's our hit list for today. The bottom line, we're going to do one problem, two ways. That's this problem up here. We're going to do a two-tailed. We're going to do it one way with critical value, a second way with the p-value, and then we're going to alter it slightly and do it two ways again, both with one tail, one way with critical, one way with the p-value. Okay. As you can see, as going into this, the name of the game is mastering the t distribution. In my opinion, this is probably the hardest situation to be in because it's the t distribution. We don't have a hack table. We have to know how to navigate the t table and all those kind of things. But if we, like many other things in life, if we put that weight on the bar first and we can master this situation, in my opinion, everything else is easier. Okay. But that's just how I see it. Okay. Again, that's belief versus fact. All right. Here's our situation for today. You are the accountant for Jimmy's Waste Management Company. And from just a quick review of the files, not even a sample, but just a quick review, you haven't consciously been collecting data, but you're kind of looking at things and you start to believe that the sales department has been overcharging customers within the last several months. Now, there's more than 80 records, and you don't have time to do a full audit of all these records to really explore this belief that you have. So you have to do something a little bit different. But the $1 million question in your mind, actually it might be more than $1 million, is the sales department overcharging the customers? Okay, so that's our setup. So with that in mind, we're going to go in here. We've got our population mean. Sigma is unknown. How do we know that it's unknown? Well, for one, it's not specified. Okay, if you look here at our orange, kind of off orange, like a rotting orange, I don't even know what color that is, but there's no standard deviation in there. We could shake that box. It's no standard deviation in there. However, there is a mean, which is that 120. That very clearly is not a proportion. It's a mean. Okay. So sigma is unknown, and the words has changed is kind of that key word to saying it either is or it isn't. Notice what we don't have is that we feel that it's become greater, although that's in the overall situation. But in this specific approach to the problem, because we feel that it has changed, that leads us to the two-tailed test. It either is or it isn't. Okay. And then for this one, again, in real life, you could choose critical value or p-value. I'm going to direct, in this instance, we're going to solve this with the critical value. Okay, so let's look at what we have here. All right, good to go. So first things first, our critical value steps, which are the same critical value method steps that we have regardless of the situation. So the first step is state the null and the alternative hypothesis. Travis, what do you think is the null hypothesis in this case?
Because it's two-tailed, it's going to be different. Well, obviously. But M is less than.
Okay, less than what?
120.
Okay.
And then, is it less than or equal to?
You tell me.
Less than or equal to 120. And then it's M is greater than or equal to than 120.
Okay, you're definitely headed in the right direction. Because of this right here, this is my way of saying it either is 120 or it isn't. Okay, and plus we know this is a two-tail. All right, what you described about being greater than or less than, we are going to do, that'll be our one-tail version of this.
Oh.
Okay, but as we see it right now, this is another way of saying this symbology right here. It either is or it isn't.
Okay.
Does that make sense?
Yeah.
This says that it has not changed, and this says that it has changed, but it doesn't say whether it's become more or less. Okay?
Yeah. Okay.
All right. Okay, super. All right. Step number 2, our level of significance, which is given to us 0.05, and our sample size. So, Jack, what is our sample size here?
Would it be 12?
It would be 12. Very good. We select a sample of 12 orders. Here they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. So we're not going to do anything with them yet. We just have them up there. So that takes care of step number 2. Let's go to step number 3. Because we have this situation, population mean with the sigma unknown, we are going to roll with the t distribution. Now, let's talk about first and we're going to, because we're rolling with the t distribution, I'll just put t dist. Okay. And we're going to be rolling with this t statistic. All right. Hand in hand. Can't have z and t. Both got to be t. All right. Just to keep our brains working, Tim, any guess on what that might look like? I'll give you a hint. It's got.
Equation for it?
Say again?
The equation for it?
Yeah, just guess. You don't even need to have it perfect. Just let's talk about the numerator. What do you think's involved in the numerator?
Well, let me look back at my notes. That t would be, is that the alpha half? Would it be like something like that, or
we're gonna need to use, you were onto it. We're gonna need to use alpha half in a little bit when we start going to the distribution. I'll give you a hint. In the numerator, we're gonna have our old friend x bar, and we're gonna have our old friend population mean. So that isn't any different so far from the z stat. Joel, what might be in the denominator that would be different?
I'm going to say the sample standard deviation.
Very good. And why would you say that?
To be honest, because it was the only, I mean, it's in the equation, but it was the only variable that wasn't used. So I figured it had to be in there somewhere.
Yeah. And the other thing is we don't know the process standard. We don't know the population standard deviation. So when we don't know that, we have to use a sample standard deviation. Okay. So this is what our t-stat looks like. And just to reinforce the point, the only thing that has changed in the equation from z-stat to t-stat is that s right there. Okay. N is still n. X bar is x bar. Mu is mu. Okay. So determine the appropriate test statistic and sampling distribution. We just did that. T-stat. We have our formula here. T distribution. I have our tables nearby, but we don't need to go to them just yet. All right, let's go to number 4. Determine the critical value, rejection, and non-rejection regions. Okay, let's do the critical value last. Let's go to some familiar territory with rejection and non-rejection regions. Again, old friend, we know that this here is 120. All right, we're going to have a rejection region out here and a rejection region out here because this is a two-tailed test. And we know it's a two-tailed test because of this language here has changed. And because of this symbology here, it either is or it isn't. So we're going to have rejection out here. We're going to have rejection out here. We're going to have do not reject right there. Okay. So when we look back here at this step, determine the critical value, rejection and non-rejection regions. Okay. Rejection region, non-reject. But we got to know this critical value, or these critical values. We're going to have two. It's going to be the same value. It's just going to be one's positive and one's negative. Okay, because we have the normal distribution and it's symmetrical. So here's where things get a little dicey. We just got to know what we're doing. When we think about T, we've been here before. And Tim mentioned one thing earlier, alpha half. So remember with T, whenever we're rolling with T, we got to know two things. We got to know alpha half. In this case, alpha half is simply half of alpha. So we take 0.05 and divide it by 2, and that's 0.025. Hannah, what do you think the other thing we need is before we go into the T distribution table?
The degrees of freedom, so 12 minus 1.
Roger that. So 12 minus 1 is 11. Okay? And that's no different than when we've dealt with the T distribution before. Degrees of freedom, alpha half, degrees of freedom, alpha half, degrees of freedom, alpha half. I would like fries with that. So with these two things in mind, we're going to go into our T distribution. Now, same. I know what you're thinking. Well, this table isn't the be all end all. That is correct. If you have something over, I don't know, upwards of like 30, actually it's 40, then you need the table from your book, which looks like this one that Jennifer provided. That's actually appendix table E3 out of your book. So I think with Pearson this weekend, or hopefully before that, you'll need this table, which is on Canvas. All right. And you just keep on going down to whenever you get the degrees of freedom you need. For our problem today, we're going to use this table right here. And just to, oh, wrong direction. Sorry. Boom. All right. So same as before. We want to go down here. That's going to bring up a bunch of junk that I don't want. Sorry. I'm just going to do it with my cursor. So I'm going to go down here, degrees of freedom to 11. Boom. And I'm going to walk over here till I find 0.025. Boom. And that's right above my cursor, 2.201. 2.201. 2.201. And you can actually do this during the exam because no one's going to be there that you'll be distracted anyway. Okay. 2.201. Matt, I know you're laughing at this somewhere inside. Okay, 2.201. That's this critical value, 2.201. This one over here is negative 2.201. Okay. So my decision rule, if I'm setting up a decision rule, my decision rule would be that if T-stat, I'm just going to abbreviate it like that, is greater than 2.201, I will reject. And if T-stat is less than negative 2.201, I would reject. Because in this first case, I would be out here somewhere in the rejection region. And if the second case were true, I'd be out here. Only one of these is I'm only going to have to use one of these decision rules. Okay. It's not going to be both greater than or less than. Okay. But it all depends on what my T-stat is. Okay. So here's all that. Here's all that. Here's this, my critical value. All right. So that takes me to step number 5. Collect the sample data, organize the results, compute the value of the test statistic. Okay. Let's go up here to my test statistic. X bar. Uh-oh. How do I figure out X bar? Huh. Alyssa, how do I figure out X bar?
Would you just add up all the values and then divide them by how many there are?
Roger that. That's exactly what I would do. Outstanding. And my chicken is asleep, but if I add up all these values and divide by 12, as Alyssa told me to do, I get 112.85. Okay. And then I subtract 120. How do I get S? Greg, how do I get S?
I actually can't remember.
Lexi, how do I get S? What do you think?
Would you take the difference between your mean and then one of the critical values?
For S?
Yeah.
No. Jared, how do I get S?
Is it similar to the equation for just finding the standard deviation of like a normal population or just like mu?
You mean like this?
I guess, yeah.
Okay. Remember this old dude? Notice what's different? I don't put a P here. I put an S there. All right. And then I highlight all these values. So I'm going to have an array in there. All right. There's a longer way of doing it. You can do it by hand. Off the top of my head, I can show you how to do that, but I think most of us would probably prefer to use this way. So that's what I'm going to stick with for now. So S, I got to do that Excel function, sdev S, put that array in there for these values. And in this problem, that equals 20.8. And then I'm going to take the square root of 12. Okay. Got a lot going on here, so just make sure we don't make a mistake. And all that equals a T-stat of negative 1.1908. So Travis, what do? I have a T-stat of negative 1.1908. Do I reject this null hypothesis or do I fail to reject it?
Well, it's saying they suspect that the sales are supposed to be or have changed from 120, and they obviously have. So, well, in this little sample, so yeah, you have to reject it.
Okay. So this value here, negative 1.190, that is my test statistic, my T-stat. And so does that, based on these decision rules or these critical values, where does this value fall? Does it fall out here?
No, it falls in the middle.
Okay. And what region is this?
Do not reject.
Right.
Uh,
Okay. So that's why doing these steps, and personally, just so that I'm clear with everybody, I'm not going to ask you something like, Tim, tell me the fourth step of the critical value method. That is not interesting to me. But I will say, Tim, here's a problem, man. Do you reject or fail to reject the null hypothesis? Use the critical value method. Okay. So, Tim is probably going to want to pull out his little cheat sheet and follow the steps. Okay. And I might ask him, hey, why did you do that and everything? But I don't care. So don't spend any time trying to like memorize this. Okay. But do use it so that you get to the right conclusion. Okay. So based on this value, being in this rejection region, okay, and it would be this decision rule right here. All right. It's not less than negative 2.201, which reflects this. So we would fail to reject, okay, the null hypothesis. So based on that, it hasn't changed, okay, not significantly at least. Okay. Questions on this method? All right. Let's talk about the p-value version of this. Oops. Okay, same, nothing has changed. So I'm gonna run again for just a little bit to get us to where our quote point of departure is in the differences. So HO mu equals 120. Alternative, mu does not equal 120. Step 1. Step 2, alpha 0.05 and 12. Awesome. Step 3, rolling with T, because we've identified we don't know the process or the population standard deviation. So we're going to be rolling with T distribution and T statistic. And we remember that our T-stat formula is X bar minus mu over sample standard deviation square root of n. Okay, so that takes us through step number 3. So I'm going to just border this off with kind of that is all the same. Okay, on this side. Step number 4 is where we start to go into some different things. Collect the sample data. Okay, we still have to compute what X bar is and what standard deviation is. Okay, so to do that, we would add these up, divide by 12 like we did before, and that would equal 112.85, and then standard deviation. Remember our Excel sdev dot p, or excuse me, s, and put in this array, and that has not changed from 20.8. Okay. And here we go. Compute the p-value. All right. This is where things get interesting. So I'm going to put a little star, okay, for the p-value. So the way that we compute the value, the p-value, depends on this right here. And okay, so depending on that, we're going to do, we're going to make our selection. first of all, we've got to go to Excel. There's no way around it. There's no table we can do to get this. We have to use Excel. All right. So we are going to start with this formula, t.dist. And once we start typing that in Excel, Excel is going to want to give us options. Okay. When we have a two-tailed test, we are going to want to choose this option here, 2t. All right. Okay, so that's the first very important thing. Now, the second important thing is Excel is just going to pop up and it's going to start writing the equation for us. But it's going to ask for x. I have a colleague of mine that says he takes like a selfie of the class at this point and says one of you is going to make this mistake. I don't like doing that at all. But this x, you need to understand that x is asking for the t-stat. Okay, it's not asking for x bar. It's not asking for racer x or any other kind of x. It's asking for the t-stat. And in addition, so caution, caution, Excel does not, this equation does not accept a negative value in there. Okay, so for our example here, our t-stat, remember, if we put these values in there, we get that t-stat of negative 1.19. You can't put negative 1.19 in here. It won't take it. It'll just give you it. It's kind of Excel's way of saying, I'm not playing like a value exclamation point. Now you can try it. I mean, your machine's not going to fry, and Excel will give you the error code that if you look up this function, it'll kind of tell you what you did wrong. I'm just trying to save you that heartache. Okay. So for our example here, we're going to put 1.19 in there. Now, the other thing that this equation is going to prompt you for are those degrees of freedom. And remember, degrees of freedom, n minus 1. So in this case, we would put 11. All right. All that's going to give us a p-value, in this case, 2.588. Okay, so that takes us through step 4. We have a p-val of 0.2588. We go down here and set up our little diagram with alpha, the artist formerly known as the fish, p-value 0.2588. And just off the bat, by now being the mad skill, mad warriors, et cetera, everything mad, we know that that p-value is just too doggone big. And especially is too big compared to that. So we know that that is greater than that, but the alligator is not eating the fish. If the p-value is lower than alpha, then the null must go. It is not. It's actually much greater than alpha. So we would fail to reject the null hypothesis. Okay? So, quick recap. Everything is the same until we get to step 4 and compute the p-value. To compute the p-value, we first got to get the right Excel function. We start with t-dist. Because this is a two-tail, we're going to get that 0.2t. And what we do in a one-tail, we'll talk about here in a second. In fact, I think I'm just going to skip to it because because we got about 15 minutes left. So we'll go to that immediately after this problem. From there, it's going to ask us for X. Don't get fooled like the WHO. Put in the t-stat, but make sure it's not negative, even though your t-stat is. And remember, it doesn't really matter because the distribution is symmetric. So put that in there and don't forget your degrees of freedom. That'll give you your p-value and do your comparison. And fail or not fail or reject or fail to reject based on what that outcome is. Okay? Potentially the hardest one of the entire bunch because you got to do a lot of thinking. The good news about this, you don't have to go into the t-table. The bad news, I suppose, is you got to figure out this stuff here in Excel. So pick your poison. The main thing is get reps in, and then nothing is bad. You can deal with anything. Questions on any of this?
I have a question. This might be a dumb question, but I'm going to ask it anyway.
There are no dumb questions.
To clarify, the t-dis.2tail blah, 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 blah is to get the p-value, correct?
Absolutely.
Okay, that's all I wanted to clarify.
Now, super question. Okay, other questions?
So with the two-tailed test, Excel is the only way to get the p-value?
Yes.
Because I actually did the homework yesterday and managed to get the p-value without Excel, but then I remembered that those were one-tailed tests.
Yeah, so there's there's other ways you can do it in Excel, and the book will show you the way that has this like stat pack where it gives you a whole bunch of info. But the bottom line is whether you use stat pack or use this equation, you still have to be in Excel. Okay, I don't teach the stat pack stuff because I don't know, maybe I should, but it kind of seems like more information that potentially is more confusing. I try to just kind of teach what people need to keep doing problems. I don't know. I might be doing people a disservice, but the bottom line is you got to be in Excel, or I guess there's other programs like JMP that the book talks about and other things like that. Does that kind of answer your question, Greg?
Yeah.
Okay. So let's jump to a one-tailed version of this and do a p-value problem. So, and I'm just going to pick it up a tiny bit. Don't let me rush you though, because I don't want to shortchange you on the knowledge, but I'm going to this one because we have about 12 minutes left. I'm not doing the critical value this way. You can do it on your own. I will put out the quote answers or my notes to this later. I think I still owe you ones from the other day. So here we go. What has changed between the two problems? You believe that the average amount per sales order has increased from 120. Okay. Everything else is the same. So I'm just going to rock through this. Stop me if something doesn't make sense. So we're back to the mean, that magic 120, and the null would be that it has not decreased or it's less than. Actually, we're not going to connect it to. We're going to say it's less than or equal to 120. And then what we believe is the opposite of this, that it has increased. Again, we have no equal sign there. By the nature of this, these dudes right here, this tells us that it is a one-tailed test. And because of the nature of this, and I don't want to get confusing symbols, in the relationship of mu, to this greater than sign, this tells us we're going to be working in the right tail of the distribution down here when we do that one-tailed test. Okay, step 2, level of significance and sample size. Alpha is still 0.05, sample size is still 12. In terms of step 3, appropriate test statistic, we're going with t-stat, again, because of this situation here, and we're going with the t-distribution. Okay, cool. Now we're back to step 4. Collect the sample data, again, to get X bar. We're going to add all these and divide by 12. That gives us the same value that we've had before, which is 112.85. And we need to get S. So we're going to do all that and do our SDev in Excel, and that gives us 20.80. All right, so we have sample data, we have the value of the test statistic. Oh yeah, so we need this to determine our test statistic. Our formula is not changed. I'm just gonna write it out here. Remember our test statistics, so we're doing the t-stat, and that's X bar minus mu over S over the standard, or excuse me, square root of the sample. All right, so we have this. With that, we can compute this, and the value we get for our t-stat is negative 1.19. That's not different either. Now we're down to p-value time. Okay, same method as we just did, only a little bit different. We go into Excel, we know first thing that we're going for this function, we just start typing it in. Now, at this point, Excel is going to give us that choice of 3. All right, so it's going to give us a choice of t-dist by itself. It's going to give us t-dist to t, or it's going to give us t-dist road and track, RT, right tail. We're going to choose that one because of this here and because of this right here, because we're working in the right tail. Okay? Because we suspect that it has increased. So we're going to choose RT. Very, very important. Okay? From this point, it's the same challenges as we encountered before. And once we do that, Excel is going to prompt us and ask for X. We know that this X is really no other kind of X. What they're really asking for is the t-stat. Okay, so can't get confused there. And that's, this is a good example where, not to insult anybody, I love you all, but you got to be smarter than Excel. All right, because Excel will take any number you want and put it in there. Just you're going to get a garbage answer. Again, same. We can't put a negative number in here. Excel won't like that. We're going to take that t-stat, take the negative off, put it in there. And just the same as before, it's going to ask for degrees of freedom. And we're going to put in 11. Okay, now you might think, well, these values are the same as you put in before. Right, but this isn't. And so when we do that, we're going to get 0.1295. That is the p-value. We're going to set up our little handy dandy thing. Park that p-value down here. Park our alpha over here. And say, which way does the alligator go? Well, alligator's going to eat what's bigger, so the alligator's facing that way. And because the alligator is not eating the fish, we do not reject the null hypothesis. Or if p-value is lower than alpha, we reject. Well, p-value is not lower than alpha. It's greater than. So we fail to reject. And in the context of this problem, we think something, pun intended, fishy is going on, but we really don't have grounds to do more than believe that. Okay, the statistical analysis, the hypothesis test does not support that belief. We failed to reject the null hypothesis. So the status quo is likely what is happening, regardless of what we feel and think. Again, here we have the separation of emotion and logic, which, in my opinion, is a thing that ironically separates professionals from amateurs, which is what this class is all about. Because no more from this point on in your life will you argue and debate something with purely emotion. Maybe you will, but maybe you'll be more prone to induce some logic into things. And out of that, you will be a player. Mad skills. Questions on anything? Questions on this? Anything else we talked about?
Yeah, I just have a quick question.
Yep.
So if we were using the left side of this diagram rather than the right, is it still going to be the same equation in Excel?
No, that's a good point. So, Tim, you're talking about if we were doing something over here.
Right.
Okay. So in that case, we would choose this equation. There is no point LT. So the Excel equation, this default is the left tail. Does that answer your question, Tim?
Yeah, thank you.
Okay. And that's a very, they're all good questions. That's an important distinction. Okay. So again, once you go into Excel and you start typing tdist, the menu is going to fall down for you to pull whatever you want. Again, you got to know what you need off the menu. You don't go into a restaurant and order something that you don't know what it is. We all know how that turns out. For me, that usually turns out in a bad day. All right. So you got to know which is which. All right. And if you're searching for a tdist point LT, you're not going to find one. Okay. All right. Other questions on anything, big or small? Okay, so at this point, you have the knowledge you need to definitely prosecute and continue to prosecute the Pearson homework, and more importantly, get some good reps in. As always, I encourage reps so that this stuff just becomes habit. Okay, I know the situation. I know the situation. Please evaluate yourself and say, where do I have hangups? Do I have hangups framing? Or do I have hangups once I get in the details, or both? There is no good or bad. What the only bad is if you haven't assessed yourself. That's where I would really start to get concerned, because if you haven't assessed where your challenges are, then you're kind of going to have a harder time. And especially if you need help. But if you've done a self-assessment, that help will be much more productive. If you have questions on any of this stuff, please feel free to get hold of me. I will post my notes for this as well as from the other day. And I will hang until we clear the call. If I don't talk to you, then have a great weekend.
Thank you.
Thank you. Take care.